Welcome back to Just Academy Mathematics channel, where we make you a mathematics genius. Today we continue from where we stopped in our last class. We are still in matrix and determinant, and today we are going to be talking about or treating multiplication of matrix. Multiplication of matrix. In our last class we discussed multiplication of matrix, scalar multiplication. But in this class, we are going to be discussing multiplication of matrix by matrix. That is, a matrix multiplying another matrix, not just a number multiplying a matrix, but a matrix multiplying another matrix. So it's going to be an interesting class. Make sure you watch all the series. In this multiplication of matrix by matrix, we are going to be having 3 different classes in order to help you understand it in detail. This is very, very important. This multiplication of matrix is very, very important in understanding other sub topics under matrix and determinant. So let's go there. 2 matrices. You can see my write-up, a brief write-up, just to give you an idea of what we're talking about. 2 matrices can be multiplied together when the number of elements in the first row of the first matrix is equal to the number of elements in the first column of the second matrix, regardless of their dimension. Regardless of their dimension means, for instance, look at these 2 matrices. They don't have the same dimension. This matrix is called a 2 by 3 matrix. Why? This is 2 rows and this is 3 columns. 2 by 3 rather. A 2 row and 3 columns. 2 by 3 matrix. Why this is called a 3 rows and 1 column. 3 by 1 matrix. The dimension is not the same. But what will guarantee whether the multiplication can be possible is only when the number of elements in the first row of the first matrix. This is the first matrix. How many elements do we have in the first row? 1, 2, 3. 3 elements on the first row in this first matrix. Now, it must tally with the number of elements in the first row in the first column of the second matrix. The only column in this matrix is this column, 1 column. How many elements are here? 1, 2, 3. Because this is 3 elements on this first row in this first matrix, tallying with 3 elements on the column in this second matrix. Therefore, this matrix multiplication is possible. But if they are not tallying, the multiplication is not possible. Unlike addition of matrix, for addition of matrix to be possible, the dimension must be the same. So if this is 2 by 3, this one must be 2 by 3 for you to be able to add them, or else you can't add. So assuming we are asked to add this now, it's not possible. The operation will not be possible because this is a 2 by 3 matrix, while this one is a what? A 3 by 1 matrix. So you can't add. But for multiplication, you can multiply only when the row, elements in the row, the number of elements in the row is also equal to the number of elements in the column. I get what I'm saying? So this is how the operation works. You will get more as we take examples. We want to multiply these 2 matrices, then AB means A times B. Now notice that the first entry on this first row is A. We multiply the first entry on the second column, on the first column, this only column, we have only 1 column here. So A with times P, look at it, A times P. This B here, second entry with times this second entry here. That is B times Q. C with times R. Can you see the movement? Now, that is the first one. Then the second one, you take the second row, you still times the same column. B with times P, E with times Q, and F with times what? R. So when you add them together, you will get your matrix A times B. So the movement pattern is row multiplied by column, as shown below. You can see the arrow. You pick this row, it will times this column. You pick the second row, it will times this column. So if it's more than one column, it's still the same thing. Row times column, the same row times the second column. Row times column, the same row, depending on the number of column or row. But the movement is row, column, row, column. So that is how the multiplication move. So example will help us understand better. Let me show you a couple of examples. Now look at the first example we'll be looking at. Look at the example 1. Look at the example 1 here. Now this example 1 say that given that matrix A is equal to 3 minus 4, 5, 0, and matrix B is equal to minus 1, 3, minus 2, 1. They want us to find AB, they want us to find BA, then they want us to comment on AB and BA. Let's see. So let's put the solution here. AB means A times B. So this is AB equals to, what is matrix A? 3 minus 4, 5, 0. Multiplied by B. What is B? Minus 1, 3, minus 2, 1. Now, let's do the multiplication. So, AB is equal to, let's go there. Remember, I just told you that this row times column. The multiplication is possible because this is 2 elements here, 2 elements here. So, 3 times minus 1, that is the first operation. 3 times minus 1 plus the next one is minus 4 times 2. 3 times 1, 4 times 2. Row times column. First entry times first entry. Second entry in the first row times second entry in the first column. So the next one will be minus 4 times minus 2. That is for this. Unfortunately, I will be needing space here. Okay. We are not done with this. This time, this is what we have just done here. The next one is 3 with times 3. So we have 3 times 3 plus, let's squeeze it in there, minus 4 times 1. Minus 4 times 1. Pardon me. Now, that is for this first one. This times this 1, then this one times this one. Now, let's go again. We go with this. 5 with times 1 minus 1. 5 times minus 1 plus 0 with times 2. Row column. 0 times minus 2, comma. Then we go again. 5 times 3. Row column. 5 times 3. Then plus 0 times 1. We cover the brackets. Now let's proceed further. So AB is equals to, what do we have now? 3 times minus 3 is minus 3 plus, this time this is what? 8, comma. Then this 3 times 3 is what? 9 plus, look at this first. Minus 4 times 1 is minus 4. Okay, let's just put it like this first. That is minus 4. Then for here, we have minus 5 plus what? 0. And then finally, 3 times 5 times 3, 15 plus 0. So finally, B times A will give us what? Minus 3 plus 8 is what? 5. Minus 9 times 9 minus, this time this is minus. Plus times minus is minus. 9 minus 4 is what? Of course, it's also 5. It's also 5. Then this is what? Minus 5. And y here is what? 15. So that is the operation for A times B. Are you with me now? Now, let's go and see the operation for B times A here, over here. B times A. Hope you will see. Let me adjust it a little. I hope we will be able to capture everything. Okay. B times A. So let's have it here. B A is equals to what? We times B first. Minus 1 minus 2, 1 times 3 minus 4, 5, 0. That is B times A. So let's go. We do the same thing. BA is equals to, now minus 1 will times 3. 3 will times 5. So we have minus 1 times 3. Then plus 3 times 5. That is this times this. Minus 1 times this, 3 times 5. That is the first possibility. Now the second one is minus 1 times minus 4. Then plus what? 3 times 0. That is the second one. Now let's go. Minus this row times this column. Minus 2 times 3. Minus 2 times 3 plus 1 times 5. Then second row times second column. Minus 2 times minus 4 plus 1 times 0. Are you with me now? So therefore we conclude that A times B is what? Minus 1 times 3 will give us what? Will give us minus 3 plus what? Plus 15, comma. Then we have minus times minus plus 1 times 4. Minus 1 times minus 4. 4. Plus 0. And we have what down here? Minus 6 plus 5. And we have what again? We have 8 plus 0. So we conclude that BA is now equals to what? Finally, minus 3 plus 15 is what? 12. And 4 plus 0 is what? 4. Then here will give us minus 1, minus 6 plus 5, minus 1, and what? And 8. So this is the matrix AB, and this is BA. Now, notice something, because we want to answer III. III is a comment on what? A and B. Notice that A times B is not the same thing as B times A. A times B is not the same thing as B times A. So first, in our comment, note that AB is not equals to what? BA. What does that mean? It implies that what? It implies that what? It implies that A and B, matrix A and B, are not commutative. What does it mean to be commutative? Commutative law in algebra, a math states that assuming they are commutative means, this is the meaning of commutative. Commutative for multiplication means that 3 times 2 is equals to 6, and 2 times 3 is also equals to 6. That is commutative. Notice that 3 times 2 is 6, 2 times 3 is 6. It doesn't matter the one that comes first. But for matrix, a matrix A and B are not commutative. A times B is not the same thing as B times A. So A and B are not what? Commutative. Does that make sense? So that is what you need to know. But there is commutative for addition. Matrix A and B, if you add them together, is going to be the same. A plus B is the same thing as B plus A for addition. But remember that for addition to be possible, the dimension must be the same. But for multiplication, two matrices, as you can see now, are not what? Commutative. A times B is not equals to what? B times A. Let's take it further. Let's do one more for this class. Now, look at example 2 here. Let's take this example. Look at this matrix. We are asked to find A times B again and B times A, and hence we are asked to state our observation. So let's solve and see what will happen before we can be able to make any observation or comment on it. I get what I'm saying? Okay, so solution, we want to find A times B. Look at it now. AB is equals to, what is matrix A? 2, 4, 6 minus 3, 5, 3. Multiply by what? B. What is B? 1 minus 2, 5, 0, minus 5, 7, minus 4, 0, minus 6. Are you with me? Now, if we multiply these two matrices, let's see if this will be possible. It will be possible because this is 3 entries, 3 elements in this first row of the first matrix, and this is 3 here, first column of the second matrix, so it will work. So if we want to times this now, look at, because I'm not going to show the detail the way I showed in the first one. Look at the operation now. These 2 times 1, 4 times minus 2, 6 times 5, row times column. 2 times 1 is what? 2. Plus 4 times minus 2 is what? Minus 8. Plus 6 times 5 is what? 30. That is this first row times this first column. We are done with that. We put comma here. Then we'll do it again. First row times second column. 2 times 0 is 0. Plus 4 times minus 5, minus 20. Plus 6 times 7. 6 times 7, 42. Are you with me? Comma. We are done with this again. So we take for the last this same first row times this third column. Can see first row times first column, first row times second column. Now first row times what? The third column. Let's go. 2 times minus 4, minus 8, plus 4 times 0, 0, plus 6 times minus 6, minus 36. Are you with me now? So that is the multiplication. We can put everything in big bracket now. Now let's go. Second row, we times this first column, times this second column, times this third column. So we take second row now. Minus 3 times 1, minus 3. 5 times minus 2, that is plus. 5 times minus 2, minus 10. Plus 3 times 5, 15. Now we'll go again. First, second row, second column. Minus 3 times 0, 0. Plus 5 times minus 5, minus 25. Plus 3 times 7, 21. Then finally, minus 3 times minus 4, 12. Plus 5 times 0, 0. Plus 3 times minus 6, minus 18. So we add up. We have that AB is equals to, now 30 minus 8 is what? 22. 22 plus 2 is what? Is 24. So we have 24 here. Now 42 minus 20 will give us what? 22. Then here, 0, nothing. Minus 8 minus 36 will give us minus what? 44. Minus 4 and 4. Now for this row, minus 3 minus 10 is minus 13. Minus 13 plus 15 is 2. Positive 2. Now here, minus 25 plus 21. Minus 25 plus 21 will give me minus 4. And here, 12 minus 18, of course, will give me minus 6. Negative 6. So this is the answer for A times B. This is the answer for A times B. A multiplied by B. This is what you are going to get. This is what you are expected to get. Does that make sense? Okay, that is for I. Now let's see II. II says that we are to solve for BA. And what is BA? BA means 1 minus 2, 5, 0 minus 5, 7, minus 4, 0 minus 6, times in what? Times in 2, 4, 6, minus 3, 5, 3. Are you getting it now? So let's see. Is BA. Can it work? Let's see. Row times column. This is 3 elements here. This is 2 here. So it won't work. Because 1 will times 2, 0 will times minus 3. What will this one times? Nothing. So since there are only 2 here, while there are 3 here, it will not, the operation is not possible. He said the what? The operation is not what? It's not possible. It's not possible. That is the observation. That is the observation, because they say we should state our observation. Our observation is that we cannot multiply BA. We cannot multiply BA because it does not meet the condition of multiplication. For it to meet the condition is that if here is 3 elements on this first row, the column here must also be 3 elements. But this is 3 and this is 2. So this operation is not possible. Can you see again? Again, matrix is not commutative. Are you seeing it now? Because A times B is not the same thing as B times A. As a matter of fact, for this one, this is A times B, but B times A is not even possible. Are you get what I'm saying? So that is it for this class. Make sure you watch the continuation and see more of multiplication of matrix by matrix. And make sure you share this class. That is the least you can do. Share it on Facebook, share it on all social media platforms. Make sure you follow us on Just Academy on all social media platforms, Just Academy Mathematics, YouTube, Just Academy Mathematics, Facebook. All social media is Just Academy Mathematics. Thank you. See you in our next class. And remember, if you need a one-on-one coaching, one-on-one virtual tutorial, we have more than competent tutors to take you one-on-one and help you enjoy and understand mathematics. Thank you.